Welcome. Thank you all for attending. This is the American College of Radiology's webinar for technologists on the 2018 edition of ACR's Digital Mammography Quality Control Manual. My name is Dustin Gress. I'm ACR's Senior Advisor for Medical Physics, and I'm joined in the room by Pamela Platt, who's ACR's Mammography Accreditation Program Manager and FDA Liaison. We thank you very much again for attending. This webinar will be recorded. We will post it publicly, ideally by the end of next week. It'll be on our Digital Mammography QC Manual Resources webpage. And during the webinar, you may enter questions in the box. Our presenter will show a slide to demonstrate how to do that. We will see the questions come in as we go. If we feel we should interrupt, we will. Otherwise, we'll handle them at the end. Without further ado, I'd like to introduce Eric Burns. Dr. Burns is chair of ACR's Subcommittee on Quality Assurance in Mammography. And with that, Dr. Burns.
Okay, thank you, Dustin. And thank you, everybody, for giving us an hour or less of your time to introduce the 2018 ACR Digital Mammography QC Manual, which now contains both the 2D quality control test and the 3D or DBT or TOMO components. So now one manual covers both 2D and TOMO in terms of quality control. To start, there is as people have logged in the upper right corner, I think, of your screen, there is a control panel, and if you click on the little yellow arrow, it'll either hide on the right or pop out, and you can, at the bottom, you can type in questions as we go, because that is the way that during the session we want to collect questions, and as you type them in, the ACR staff are going to be looking at these, and we are going to be collecting these and perhaps answering them either during the session or at the end or in some sort of written FAQ or document after today, depending on how complex the questions are. There's also an email address in yellow on this screen to email questions, comments, issues directly to the ACR, directly related to this digital mammography QC manual. So you might want to make note of that. Dustin mentioned that this is going to be recorded, and so if you don't catch something as we go through this, it will not be lost forever, and it's retrievable because it'll either be on the record of this, or perhaps some of these materials we can put this into some sort of document for quick reference. So we'll work on discussing that afterwards. So thank you for joining. The goal for today are to talk about a couple things. We want to introduce everybody to this new manual that was recently approved by the FDA, explain what it is. We want to try throughout the session to explain why a facility would want to switch from their current quality control program to the ACR quality control program. So we want to highlight and try and articulate why and what the benefits are of this new program is. And we feel that they are substantial and are going to be helpful to everybody, all facilities, to techs, to managers, to lead interpreting physicians and radiologists, and most importantly, the technologists, and then ultimately an improved quality program for actually evaluating systems for image quality. So we want to highlight the benefits. We want to introduce and go through at a deep enough level to explain how you perform the tests, so then you might be able to see, well, why is that a benefit? Because we feel that it's really important at the end of this session that people see, they understand what they need to do and why this may be of a benefit to them. We also want to talk about how to transition. So when a facility decides to go with this new program, what are the steps to do this? Because this is sort of a new phenomena, switching from one quality control program to another. So we want to begin and set a few examples of how this might be done successfully. And then finally, we want to end with resources on where to go to help. So that's the outline. I expect this to be maybe 30 minutes, and then we will probably address some typed in questions at the end and try and answer those that we can, and then see where we go from there. So we need to start by explaining that the ACR QC manual is an alternative standard, and an alternative standard is a issuance by the FDA to say that one QC program is equivalent to another QC program. And as a result, if that means that the ACR QC manual can 100% replace another QC manual. And that means that if you adopt the ACR program, you can stop using a manufacturer QC manual. So that, in the simplest terms, explains what an alternative standard is, and that's what this ACR QC manual is. You can stop, once you start using the ACR program, you can stop using the manufacturer program altogether. There's no overlap. There's one important definition about calibrations. So some manufacturers have calibrations that are different than QC tests. And these are specific to each individual manufacturer, and those, if it's a calibration, would have to continue because they actually input information from exposures that you might make back into the system that the system needs to continue to function. So a calibration is a manufacturer-specific requirement. It's not a QC test per se, even though it might be closely tied to a QC test. It's still a calibration. So those would continue, and we have a way to document those are being performed if you have manufacturer-specific. But those are different than a QC test. So just a little detail on that definition. So a couple slides on why we feel you may want to consider switching. And the first reason is that you would experience everyday improvements in efficiency. So the ACR manual has fewer QC tests than most all manufacturer QC tests. The ACR program has less frequent QC tests. The ACR program requires less total time being spent on QC tests. There are no more baselines in any of the tests. So for a lot of facilities, they know that there's baselines for contrast to noise ratios or signal to noise or AEC or IQST test tools. So all baselines are non-existent. And there are no more calculations of any sort. There's no more calculating anything by hand or with a calculator or relative to baselines. So those have gone away. Most all results are read or scored directly from the acquisition monitor. So now the quality control is more designed to read and interpret than it is to calculate and determine. 2D and TOMO are both included in this manual now. And forms can be either paper or electronic. So the ACR provides both of these on their websites that you can download and either print, or you can download and use them in an electronic way. So we don't totally want to abandon paper because there's still some thought that that is even more beneficial than electronic because of the sort of the details of how complex it can be to maintain electronic records. But the ACR offers both paper and electronic forms. And all the while that the ACR QC tests are more useful, more relevant, more helpful, and provide a better quality evaluation of your system. And part of that is because of that we were able to start from the ground up to develop this program. So why would we say there's better quality? Well, we have designed a much better and new Phantom that evaluates artifacts much more efficiently and better because of the new Phantom. And this it's well known that artifacts are the biggest contributor to quality control programs of what we find both for medical physics and for technologists. So the fact that we have a better Phantom that does a better job at detecting artifacts, right there, we have a big advantage over the older Phantom that the other manufacturers use currently. The ACR program is structured for modern facilities. And modern facilities these days, as most everybody knows, means that there are multiple units, multiple workstations, and at multiple facilities. So we have taken into account about how to structure the program and follow that with documentation that makes it easier for facilities and technologists to document and test as these mammography facilities grow and how these units are in different locations. We also have taken a team approach for a quality assurance committee that includes a tech, a radiologist, the management, and a medical physicist to try and bring them together in various ways, which we'll get to make sure that everybody is more involved, more included, and more aware of what's going on at every level of the QC program that enhances the end result of the QC program. And then we also wanted to devise a way to bring in the radiologist and improve their involvement and feedback into the QC program. So we have a couple ways which we're doing that, which we'll get to in a second. So that is some of the highlights of how we've improved on quality. We also are trying to make this logistically easier by making your life easier with standardization. So with some of these simplifications and reduced frequencies and having one QC manual across all your facilities and all your units, we would expect a cleaner MQSA inspection because you're not any longer having multiple vendors and multiple manufacturers of QC floating throughout. Standardization reduces errors so that if you only have to know one QC program with one manual and everybody works from that, it can reduce errors. There's no question about that. There's no more chasing manufacturer QC manuals and different versions, because we all know that every time something comes out, oftentimes there's another version that has to be followed. Current editions and future revisions of the ACR QC manual will be provided by the ACR to accredited facilities. So they will be electronic now. They are no longer paper. QC forms will be provided by the ACR, paper and electronic, as we mentioned. And this is what the cover page looks like on the QC manual. And the way you can differentiate the 2016 manual to the 2018 besides the year is that on this middle picture, it does say 2D and digital breast tomosynthesis in the middle of the page. So that is the most recent manual, and then of course the ACR, when they have updates, which will certainly not be as frequent as manufacturer updates, they will be updating and rolling that out whenever those times comes, which I do not envision in the very near future at all. Just wanted to highlight and thank the staff and participants of this QC manual. We had a cross-section of physicists, of technologists, of radiologists. We had ACR staff, and we also had a representation from the manufacturers. So it was, and I think I'm correct in saying this is the first time that an ACR quality control program has had such a cross-section of representation from all the players involved, from equipment to facilities. So there's a lot of people involved and a lot of work went into this. And then there is a link which accredited facilities either can request or have received to download a free copy of this ACR QC manual. And so this is another thing that you can request on that email address that will show up at the end also if you have not received this, and the ACR will send you a link and you can download this. So that is the overview of the manual. I want to start by introducing the actual tests that the technologist will be performing and try and explain through some of these slides that look intimidating, but they really are not intimidating. They're trying to be, a lot of information is on here because it's trying to summarize some things. So for the Technologist test, and this is both for 2D and 3D tests, we list the test on the left, we have the frequency in the middle, and then we have corrective action timeline on the right. And none of these issues should be foreign to people that have done quality control. So we list the test, and then we have a set of forms that we have what we call management forms, and these are forms that are not tests, but they are forms that I'll show shortly, but that will help facilitate some of the documentation for the multiple facilities and multiple units. We have tests and forms for mobile systems, and then we list the equipment that you would need to be able to perform these tests at the bottom. So you need a new digital Phantom. If you print films, you need a densitometer, you need a scale and towels for compression, nothing different there. And then for cleaning monitors, you need appropriate monitor cleaning materials. So in terms of the actual testing, there is a Phantom testing which is performed weekly, and there is, if you have CR cassettes, we are going to ask you to just erase cassettes weekly. So that people who have CR knows what that is. You just put that into the CR reader and you hit a button that says erase, and it just erases them. But your only weekly test is acquiring a Phantom and evaluating the Phantom. Your monthly tests are now compression thickness indicator, the visual checklist, and that is it for the unit. Those two tests, so really your three tests for the unit itself are the Phantom, compression thickness indicator, and visual checklist. None of those are necessarily different. The acquisition workstation QC is monthly, and a radiologist workstation QC is monthly. So the two display devices, both for the acquisition and radiologist, are monthly and defined as monthly, and those are very specific tests, and they're kind of standalone tests because, as you know, your radiologist workstation lives outside of your acquisition room, and it's going to basically have its own standalone QA, which is monthly. And if you print films or use view boxes, those are also monthly. There's a new test where we are asking facilities to, once a quarter, get together with a lead tech, a representative from management, and an LIP, or lead interpreting physician, to do a current review update on quality control. And I'll get to that shortly, but that is a new test. But the intention of this test is to make sure that management and the lead interpreting physician are brought into and are just updated on the QC records for the last quarter. So it's not a big test, but it's intended to be a very short but meaningful meeting between the three parties to review the QC, to make sure that the radiologist is aware of what's going on, and to support the QC program. Compression force, semi-annual, this is nothing new. And then 3 tests have been put into the optional range and called as needed. Repeat analysis is no longer a required test. It has been moved to an optional or as needed test, so facilities can implement this or utilize this test as they wish, whether it's for training purposes or for a quality check or for using for people that need some feedback. But the repeat analysis is now optional. The system QC for radiologist is an optional test, but it's more of a worksheet for the radiologist to be able to document if they think there's problems with their imaging system. And then there's a optional radiologist image quality feedback form, which is a form that can be used to give feedback on individual cases that can be used for a image quality review, or even integrated into the new EQUIP program that the FDA has implemented. So those are the tests for the technologist. Now, we all know that there's, on top of those tests, there's now TOMO systems out there. And TOMO systems have diverged a little bit in their mechanical structure and their design. And so we've had to create a chart which looks confusing here, but it's meant to sort of detail what tests you would do depending on what kind of TOMO unit you have. So in this purple box here at the top, if you use a system for both 2D and TOMO acquisition, you would choose your columns of how you acquire your 2D and 3D image. So if you just do a 2D image strictly, you would just do these tests here. If you have an add-on device, you would do the middle column for your TOMO. And then if you do 2D plus a TOMO system, you would just basically do the yellow column and the pink column. So really all this is saying is that if you have a TOMO unit, you also shoot a Phantom in TOMO mode, and you do the visual checklist for the TOMO component, and that there's a QC review and the calibrations if you have calibrations. So this is an aid to make sure that this is, you're accounting for what kind of unit you have. And if you have a TOMO unit on the far right, but you're only doing TOMO acquisitions and you're not doing 2D acquisitions, you would just do this column in terms of the testing. So don't get overwhelmed with this chart yet, but this is where this would help facilities, which we'll get to about how to work through this. So for those of you who have not seen the digital mammography Phantom, it's pictured on the left here, and it's almost the size of a large image receptor size, and compared to the old screen film Phantom on the right. So right away you can see that this covers the majority of the detector, and when you acquire the image, it allows you to view for artifacts. One asterisk here up in the upper right-hand corner is that the Phantoms now have to be purchased from an approved vendor. So vendors, to be able to market and sell the ACR Phantom on the left, the large digital mammo Phantom, they have to go through an approval process with the ACR. They have to have their Phantoms evaluated and approved. The reason for this is to make sure that the Phantom you buy is consistent and meets minimum standards, so that we don't have to worry about how the specs and the fibers and the masses may look if they weren't manufactured properly. So that is a note for buying Phantoms. This is an image of the ACR Phantom, and so what you can see is there is a circular hole that's drilled into about 1 millimeter deep in the middle of the Phantom, and that is what the physicists used for their contrast and signal-to-noise measurements. So the technologist will not even use that little circle. There's a wax insert that runs from left to right, and now the fibers and the specs and the masses are all in a single row. There's a serial number in the upper right-hand side, and when you window and level the image, which usually is not much more than what you would come up after you make the acquisition. But when you window and level to optimize the test objects, you're also optimizing the entire field of view for the whole Phantom, which means you're optimizing for the whole detector, which when you window it like this, you can then evaluate visually for artifacts. So if you have artifacts, they'll jump out at you pretty quickly, and you can see the whole detector. No longer you just see where the wax insert is on the small detector. So this is one of the primary advantages of this Phantom. What you can't see is that it's about the same, it's almost the identical thickness as the old Phantom, but you can see the wax insert and there's a cover plate. So it's almost the same thickness, but larger. So this is the blow up of the wax insert, and you can see across the top there's there'll be 6 total fibers, 6 total spec groups, and 6 total masses. There is a new pass-fail criteria, even though they are the same size as the screen film. So the pass-fail for the new Digital Phantom is 2 fibers, 3 spec groups, and 2 masses. However, the physical size of that mass or that fiber is the same size as the screen film. So that's the same size as the 4th fiber. This is the same size as the 3rd spec, and this is the same size as the 3rd mass. So the sizes of these pass-fail are exactly the same as the screen film. On the far right side, we went about 1 size smaller than the current Phantom because we realized that for some systems, they could see all the test objects on the old Phantom. So we wanted to give the next step in terms of reducing size of the test objects so we could be future-proof in this Phantom. So here's a picture of the setup in the upper left-hand corner of the Phantom on a detector. So once a week, the techs will shoot a Phantom and record the results. On the forms, there up in the upper hand left, there is a weekly designation about the frequency. You would document, is this a TOMO, DBT, or a 2D, or a 2D with add-on? So you describe what type of unit you have. And then each page, you get 5 columns for 1 per month. And then for each acquisition, you would record your results. So in this case, you record the date, the tech initials, the image receptor size, the view, if it's a TOMO unit, you would record which slice or slab, the AEC mode, auto filter in this case, the target filter, tungsten aluminum, KVP, mass, and then the only part that's really evaluating is you're evaluating for artifacts. In this case, it's a pass, and then fiber, specs, and masses. So 5, 4, and 4, and then pass. So as noisy as this form looks, what we have here is in the upper right, we have the frequency. So you can easily say, is this a weekly or monthly test? Which mode is this Phantom being acquired in? Then below that, you have the facility, the room ID, the map ID, and the manufacturer and make and model. The idea for this was that so each page would be able to be standalone in terms of having the identification of where this image was being acquired. So if you had to fax this off to the ACR or make copies, it would not get lost in the shuffle. We then have the year, 2018. We have the date and the tech initials. So here's just date and initials in this middle section. And then in the middle section is just all the technique reporting of how we acquired the image. Then we have the Phantom scoring. Then we have overall pass-fail. So it looks like a lot, but this is actually 5 weeks of data in 2018. In the bottom, we have an analysis key. So no longer do you have to remember or look up how to score a Phantom. So in this little key, you can see that the fiber to get a full point has to be greater than 8 millimeters. To get a half a point, it has to be 5 to 8 millimeters. For specs, it has to be 4 to 6 specs, and for half a point, it's 2 to 3 specs. And we give instructions for masses. If you can see 3/4 of the border, it's a full point or more, and a half a point is a half to 3/4 of the border. One of the most important changes or significant changes is we no longer subtract scores from test objects. We allow facilities, techs, and physicists to fail for artifacts. So this way, if there is something that should be repaired in terms of an artifact, you can directly report a failure and you don't have to just subtract for artifacts. So no longer are we subtracting, you're just scoring them positively, and then you can fail or pass for artifacts. And then at the bottom of each form, we have the action limits. So we have the required pass-fail criteria, and then we have a time frame. So in this case, the time frame is required items must be corrected before clinical use. So for each one of the documentation pages, we can have identification at the top. We can have the time and the date and the tech initials. We can have the acquisition parameters. We can have the scoring all on the same page, and then we can have some scoring help and action limits at the bottom. So that is sort of the design, is that these pages can stand alone by themselves, and you can complete them in front of the acquisition station. So you'll notice that there's no CNR, there's no SNR, there's no baselines. You just have to meet minimum criteria. So this is a weekly Phantom. This is probably the biggest, I guess you'd say, change, because A, you have a new Phantom, and B, you are no longer subtracting for artifacts. So those are the two things. And then your pass-fail criteria is slightly changed from 433 to 232. So that will be easy to learn. So moving on to the next test, and I'm going to speed up a little bit here to make up some time, but if you have a CR system, this is only applicable if you have CR. If you don't have CR, you don't do this test. You do this weekly. You basically record the date and tech initials of when you are racing cassettes. And there's January, February, March. So the whole year is on a single page. This is a new test for some people. But for most manufacturers, there's some sort of thickness indicator test. So what we did is we tried to make this vendor neutral and come up with a way to verify that the compression thickness is basically accurate. And so once a month, we are going to you're going to work with your physicist to come up with a test object of a fixed thickness. And in this case, what we used was 2 rolls of tape. And this, there's some descriptors in the QC manual about what you should or might use, but 2 rolls of tape, there's tape everywhere. You stack those together and you create a actual thickness is 52 millimeters. And then once a month, you put the tape, the 2 rolls of tape under the paddle, you put 10 to 15 pounds of pressure, and then you record the actual indicated thickness. And then you compare that to the actual. So this should stay within 5 millimeters of the actual thickness. So this is important, and the reason why thickness indication is important for digital systems is because that is where the AEC systems begin to choose the target filter and KVP for choosing the right dose. So thickness indicator is kind of an important thing for digital systems, which is why we have included the thickness indicator. So basically, come up with a Phantom that you can put in the drawer. In this case, 2 rolls of tape, and you just measure it once a month to make sure it's accurate. Visual checklist. This is a monthly test. This is an example for a DBT unit. The only component for DBT is that you make sure that the assembly moves as designed, because we all know that for most systems, the DBT system sweeps across from left to right, and you just want that to be smoothly. Everything up above is typical normal visual inspection checklist. We have things in bold. You'll see that like cleaning solutions available, that are critical and non-critical, but if they are critical and they're bolded and asterisked, you should be corrected for clinical use. If they're not bolded, you have 30 days. So it's a subtlety, but it's all basically, and this is an example of an entire year, January through December, so it's a single page for a single unit, and there's P's for passes in all these systems. So for acquisition monitors, we have separated that out as a separate monitor type test, and it looks like there's a lot here, but for some monitors, as people know, they are higher resolution, and they are sort of designed to be part of biopsy systems, so they have capabilities kind of like what the radiologist monitors have. So we have added a test pattern test for those monitors. If you do not have that type of monitor, the only thing you have to do is a monitor condition check, which is basically make sure the monitor is clean and there's no scratches. So in this example, if you don't have the availability to do a test pattern, you just check that the monitor is clean and there's no scratches. And you do that once a month. If you have the ability to do a test pattern, you bring up a test pattern like you have before on most other systems, and you evaluate the test pattern. And if systems have a built-in QC program, like a lot of the radiologist workstation monitors do, then you would do a verify that the monitors have passed the manufacturer test. Now, for this particular thing, it's certainly easy to work with your physicist to determine if this is required or not. But we felt that as technology improves over time, there's going to be more and more high resolution, more sophisticated monitors coming to acquisition systems. So we felt that we needed to be doing quality control tests on those monitors because they had those capabilities. But if they don't, you just do the monitor condition test, which is this one. And then an entire year is on a single page, January through February. So this is an example, like my previous examples, of an entire year's worth of data filled out. So it looks like a lot, but it's an entire year. Okay, so this is the radiologist workstation QC. Again, it's an entire year of data, so it looks like a lot. But once a month, you go to the workstation, so January through December, and you would evaluate the monitor condition, make sure there's no scratches, make sure it's clean. We're going to score a phantom on the monitor. We're going to look at a test pattern, and we're going to verify that the monitor manufacturer automated QC tests are performing properly. So this is really just 1 month. So here's January. It's 2 columns because there's 2 monitors. But there should be nothing new except for now scoring a phantom on a monitor. And you do that once a month. And so this form is intended to sit with a monitor, and then you record that for the entire year. If you're printing film, it's the same thing. It's a, if applicable, if you're not printing film, we're not doing QC. It's a monthly test, which did not highlight up here. But basically what you're going to do now, we are no longer printing strips or test patterns or anything that comes from the printer. What we are doing is printing an actual phantom that's acquired off the unit. We are scoring that phantom just like you would normally score a phantom. We are measuring the background optical density, and on my map on the left, you can see where these ODs are measured. So there's a background to the left of the circle, cavity. There's the Dmax that's measured outside to make sure it's dark enough. And so what you'll see here for the background, that it has to be greater than 1.6 OD. So there's no longer baselines for printed films. It just now has to be above or within a certain range. So for background, above 1.6. For the contrast, which is subtracting the background from the cavity, it has to be greater than 0.1. And then the Dmax should be greater than 3.1. So these are now absolute values. These are not baseline. So this is different and should get rid of a lot of headache. Not that many people print anymore, but that's how you would do your printer QC. And then again, this is an entire year's worth of data, January through December, and then everything sits on one page. Same thing for view box cleanliness. If you are doing view boxes, this form applies. If not, it does not. Here's an entire year's worth of data for your view boxes. So here's January through December, and then if you have a view box and an alternator, you just put pass-fail for evaluating your view boxes. So you can list a dozen view boxes on a single page. Facility QC review. This is a new test that we have introduced to bring everybody together on the QC team, including management, including the radiologist. It's a quarterly test, and basically what we've done is written out the minutes, the agenda for a meeting. So at the top, we have reviewing the most recent medical physics surveys and results, and it gives the room number, the date, and has this been reviewed by the radiologist, our corrective actions complete. It reports the doses from each room and the fiber specs and masses for each room. In this example, there's 5 rooms, and then on the right side, there's a little check mark that says it got reviewed. The second part reviews the Technologist QC. So here's the 1 through 10 Tech QC tests. It has a summary of the most recent Phantom with the Phantom scores, so people can get a sense of the image quality. And then there's check boxes for all the tests to ensure that they got reviewed at the meeting. And then there's a subset of more questions that might be good points for discussion, that corrective action is complete, that the technique chart is reviewed for each room, that infection control procedures are followed, off-site workstations, film printers are reviewed, service logs are current, MQSA inspections are discussed, accreditation issues are discussed. And then the second page is an area that sort of simulate a meeting agenda that talk about notable findings during the QC meeting. You can document items for quality improvement from the QC meeting, and then other QC notes. And then at the bottom, there's a place for the lead interpreting radiologist to sign, the facility manager, and the QC tech. So this documents that there was a short meeting. There are no prescription that this needs to be extensive or take an hour to go through these things, but it just needs to be done in some way that works for your facility. Compression force is no different than previous compression force tests. It's a semi-annual test, and we have just an entire year of documenting what you record, both for fine manual adjustment and then initial power drive and then pass or fail. So no changes with compression. This is our calibration optional form, if applicable. If your system has calibrations, this is where you can record if it happens in a room 1, 2, or 3, if it passes, depending on what frequency. And up here we have, in this example, every 2 weeks. So every 2 weeks there's a pass that it's your calibration. So this is really just recording. It's not a QC test. This is sort of an aid to help document that you perform some of these calibrations that are manufacturer specific. Repeat analysis, we have provided two types, a couple different forms if you choose to do repeat analysis. We have a summary form that does the entire year and does the calculations for you in our spreadsheet. So if you do a high volume facility, you may want to do a monthly. If you're a lower volume, you may want to do them quarterly. So with one form, it can kind of calculate your repeats. We have then a worksheet. So this is going way back in terms of having to do things manually. So we have a tally sheet. So if you want to tally up all the reasons that you might have repeats, they're on the left side, this whole column. It should look familiar to people: positioning, motion, artifacts. And then it will calculate, you put in your total number of images, your total number of repeats, and then it gives you your total repeat rate at the bottom. And then if you need something to collect data in each individual room, we have a daily counting sheet. So here, for each patient, you would write down number of images, number of repeat exposures, and the reasons. So this is an optional test now, the repeat analysis, but it gives you the framework from going from totally manual all the way up to sort of an electronic calculation of a repeat analysis. So we provide that tool for facilities in this program. This is another as-needed test. It's a radiologist image quality feedback form, which is really designed to be for individual patient reviews. So this is an optional test that can be used for some of the potentially the equip requirement, where each patient may receive a review where the radiologist fills out patient ID, and then they give comments in terms of what they are reviewing, and if it's an excellent assessment, good, needs improvement, or needs repeated. So this form is a model for individual patient feedback. And then if there are additional images needed, they can document that at the bottom. And this test and form may be useful in meeting your equip requirements. So that's embedded in here. There's another test for the radiologist, which is not a tech test, but we put this in here as needed, because sometimes a radiologist may say, well, how do I know my system is functioning properly? And then after I evaluate it, how do I document it? So we provided a page for the radiologist to do their own test. So basically, they pull up a case, they write down some of the demographics, they put the same image on the same monitor, and then this worksheet asks them to look at a bunch of issues to say, if you compare the same image on the same monitor, are there differences between the monitors? And then they can document this here, and they can use the checkbox. So this was designed to be a menu-driven sort of checklist for the radiologist. So this is an optional test if the rad feels like there's some issues. We have a new corrective action log that is 1 page per event. So we can document fully the beginning and the end of a corrective action event. Starting with the facility information, we can document what test failed. We can describe the test that's failing. We can then document who and when we called people. So in this service manager and physicist, we put in a call on December 12th at 7:30, and then the actions that followed that were A, B, and C till it was resolved. And then at the very bottom, there's a confirmation. Was it resolved? And did you get documentation from the service engineer? You can check yes, yes, and then you sign and date it. So the intention here is to give you a worksheet every time something comes up. The tech or facility would pull out this form, they'd initiate the corrective action form, and then once it's resolved, make sure everything is complete in terms of documentation, and then sign off on it. Instead of just keeping random QC notes for corrective action. So here's the beginning. So we have 2 forms that are designed to help keep track of all your off-site equipment. The first form is a list of your off-site display locations. So we all know that rad workstations live these days not all in your facility, but some live elsewhere. So this roster, you would list all of where you're at and then where all your workstations are. So now you can have a list of facilities with their location, address, and map ID. And so here you're saying, I have 3 different places that I have workstations off-site. And here our example says Virginia, Washington, D.C., and New Mexico. So things can be all over the country nowadays. So that's just your facility roster. Then each place that has display devices that are funneling into your map ID or where your acquisition units are can have this facility display device QC summary checklist. So they can then summarize where they are and what equipment they have. So in this case, for an entire year, you can say, well, we have a reading room, a laser printer, and 2 view boxes that are at this offsite location. And then since C is being done on monthly basis, then each month the tech can put the date and initial that it got performed. So this is sort of a summary sheet of them performing the QC, and at the bottom, the physicist can put the date of when they did their annual evaluation and their initials. And then this form is what can be sent to the facility for their MQSA inspection. So then they can have a summary sheet of where all their workstations and all their display devices live, and to ensure that those monthly QC events happen. So this is one advantage of the program to be able to handle all your offsite equipment. This form is a summary checklist. So this is sort of the summary of everything we just went through of all the QC that would happen on a unit. So here's 6 months, January, February, March, April, May, June. And you can see here are the required tests that the tech would do. So once a week, Phantom image. So there's 5 boxes because sometimes there's 5 weeks in a month. So the Phantom has 5 boxes. CR erasing, 5 boxes. Compression thickness is monthly. Visual checklist is monthly. AW monitor is monthly. Compression is once every 6 months. Calibration, if applicable, may be once a week. Facility QC review and repeat analysis is optional. So with this summary worksheet, it just sort of gives you a snapshot of what you need to do and then did it get completed. So this is a nice worksheet that can be outside of the room. So with this program, you should expect some new things from the physicist. We will generate a single one-page summary form for our annual testing or initial testing. We will provide a single one-page corrective action form if we find corrective action is necessary. We will provide a single one-page report for the workstations or monitors or acquisition monitors. We will provide a technique chart for 2D and 3D imaging. We will generate a summary letter that goes directly to the radiologist, informing them of important results, basically focusing on image quality scores and the doses that we find. And this is because we want to get this directly in front of the eyes of the lead interpreting physician. We also can provide the tech with a dedicated form with acquisition parameters for the ACR Phantom. So there's some things that will come from the physicist that will help the tech start with their QC, like does their acquisition monitor have a test pattern? How should we acquire the Phantom in 2D mode? How should we acquire the Phantom in 3D mode? So the physicist now will be giving you these forms and making it easier for you to do your imaging and your QC. So let's move on. A few minutes left for transitioning. So, and these may take a while to digest because there's a lot here. But in order to transition to the new manual, a mammo unit must have an annual physics survey, and we'll call this the transition survey. Once the mammo unit has had this physics transition survey, it is now in the QC program, and the tech can begin performing the new ACR program. So the physicist tests, and now the tech can begin. The unit's transition survey starts the one-year clock on display devices requiring their transition surveys. So what this means is if the physicist tests a single unit in your facility, then all the workstations have then 1 year from that date to get their ACR physics survey on that workstation. So you have 1 year to do that. So each display device has a transition survey, and it must continue on the manufacturer program until the physicist gets to test on the ACR program. And then upon having the display transition survey, the display device is then in the QC program, and the tech can begin doing the ACR program. So again, it's a 1-2 punch. Physicist tests, then the tech begins. Same thing for the unit, same thing for the workstation. Each display device needs to have a transition survey with 1 year of the mammo unit. And after each transition survey by the physicist, the technologist should begin their ACR tests, and this date should be noted in the QC book. And at this time, after the physicist does their test and the tech starts their QC, you can then stop doing the manufacturer QC. So that's the simplified big picture. So I have some practical steps here about what you need to do when considering this. The first thing you need to do is order or buy a Phantom from an approved vendor. Then we recommend that you have a meeting with your lead tech, your facility manager, your medical physicist, and radiologist to sort of talk through the implementation plan and schedule it, because we all know that all the units and workstations are sort of on different testing schedules, and you kind of have to figure out what order and how to optimize that. And again, to begin, the physicist must test the unit before the tech can start tech QC. So this is one of the big take-home messages, is that before a unit or workstation can go into the transition to the tech QC, the physicist has to test the unit. After the physicist does the testing, then the tech must start the ACR program. So you can't wait 6 months to do the tech QC if the physicist did the testing 6 months ago. You have to follow it directly after the physicist. The ACR does not need to be notified of this date or this happening. This information will be reviewed by MQSA inspectors during your annual inspection. So as long as you note this transition date in your books, That's all you need to do. You do not need to call the ACR. For display devices, it's the same process. The physicist tests using the ACR QC, and then the techs follow with the ACR QC. After the first unit is tested by the physicist, all display devices have 12 months to be tested, as I mentioned. In the meantime, facilities should continue with manufacturer QC for the displays until they've received their testing. So here's a note. The key to successful transitioning comes from the initial group meeting, where you develop a schedule for each unit and display device and having proper methodology being performed, manufacturer versus ACR. So you just don't want to mix up which QC to be being performed. So you don't want to switch to the ACR until the physicist has done this testing. But you can overlap where you're performing ACR on a unit before display or where it's display that have been tested before all units are tested. So in other words, you can use a phantom, a large phantom tested on one unit and use that for all your workstation testing. So a physicist could say, well, I'm going to test off of one unit and then go out and test all the displays so that they're done. And then you can start doing your testing, the tech testing on those displays, and then catch up. So it doesn't necessarily have to mean you have to have all your units tested and then all your displays tested afterwards. You can test one unit, test all your displays, or a subset of those. So you can kind of mix that up, which is why that initial meeting is so important. So I'm running out of time, but I want to talk about, I'm going to let people read this from the handout at the end, which I think the ACR can generate a PDF of this. But again, it just talks about having a meeting, laying this out, and then potentially having overlapping training before the physicist test. So it's good for the physicist and the tech to get together and train each other on the tests. And then determining what kind of units and what kind of paperwork needs to be put together. So the physicist and the tech knows the tests. The tech starts doing testing before the physicist so they can practice. And then once the physicist does the physics test, the tech can just carry on and keep going. There's no real impact of when the physicist does that, besides they can stop doing manufacturing QC. So it's that 1-2 step. And finally, where do you go for help? Resources. The website has everything from the ACR. So they, in their first page, they have an important announcement section where they talk about all the links to the application process, the new manual, the resources, and the webinars that we can go back and watch some of this for help. There's also frequently asked questions where a lot of the answers and answers to your questions will be published from today. They're going to live in this FAQ. There's the next page on their website, talks about quality control forms and equipment forms. So you have the rad tech and the medical physics forms, and the links are on their website. Here's where you can talk about purchasing the manual and the FAQs and the Phantom scoring key, and then the Excel worksheet forms. So these are all on this ACR Digital Mammo resource page. And then at the bottom, it lists the approved vendors for the ACR Phantom. So right now there's 5 vendors: CIRS, GAMX, ProProject, RaySafe, and SuperTech. There's also links to this on the medical physics forms, where they talk about the forms for the summary pages that the physicist needs, which is more for the physicist than you. And so the resources, we would say, are the manual itself, the website, the training webinars, your actual medical physicist, and then if all else fails, calling the ACR, of course, and they're always happy to help. So the last question, I know I'm running out of time, is it worth switching to the ACR Digital Mammography QC program? And my answer is yes, for reasons such as ease of learning, ease of documentation, less tests, less time need for performing the test, no baselines, no calculations, better forms, better handling of offsite equipment, better handling of multi-facility situations, better Phantom, and most importantly, an overall superior program that focuses on quality while respecting the time and resources of mammo facilities. So with that, we may have run out of time. I'm going to turn this quickly over to the ACR to finish up, but please type in your questions, and thank you for your attention.
Thank you, Dr. Burns, very much. We are, as he said, out of time. We're going to answer a couple of very quick questions. First and foremost, please go to our Digital Mammography QC Manual Resources page or the ACR Accreditation Mammography page. Download our FAQs, QC Manual FAQs. There are a lot of answers to the questions that we saw in that document. So that's first and foremost. Secondly, for cost of a Phantom, please contact a manufacturer. Our program requirements document has the manufacturers in there. Also, toward the bottom of our Digital Mammography QC Manual Resources page, you'll see a list of manufacturers that are hyperlinked to their sites. So lastly, I'm going to ask sort of a two-part question of our FDA liaison and mammography accreditation program manager, Pam Platt. Pam, do facilities have to switch to this program? And secondly, when will MQSA inspectors be ready for this program?
So the answer to the first question is no, facilities do not need to switch to this program. It is your choice. The ACR manual is an approved alternative standard under MQSA, which means it is considered substantially equivalent to the manuals that are out there. So the test and the manual has been approved by FDA MQSA program, and facilities are allowed to switch to this manual and do the QC in this manual and not their manufacturer's QC test. The second question is, are inspectors ready for this manual? MQSA inspectors were advised when the DM QC manual was approved in 2016 for just FFDM that facilities had the choice to use this manual at that time, and MQSA inspectors have been advised by headquarters that facilities have the ability to choose to use this manual at this time.
Thank you so much, Pam. Thank you so much for attending. A couple of notes. The video of this webinar will be posted hopefully by the end of next week. We'll put the link up on our Digital Mammography QC Manual Resources page, along with a PDF of the slides that Dr. Burns presented today. So thank you all so much for attending. Have a great day and a great weekend.